Now again it is time for self-assessment, and we are here with a list of questions that had come in previous JEE and NEET examinations. So let us see how much you have learned till now. Let us start with the first question. Two particles are projected from the same point with same speed u such that they have the same range. Okay, here range is same but different maximum heights h1 and h2. What is the relation among r and h1, h2? Okay, let us start with the range. Here it is given that range is same. So if range is same, we can consider that projection angle for first particle should be equal to 45 degree plus theta, whereas for second projection angle is equal to 45 degree minus theta, because as we know, if two particles have same range in projectile motion, they must be complementary to each other. That is, sum of their angles has to be equal to 90 degree. So I have considered projection angle for first particle to be 45 degree plus theta and for second 45 degree minus theta. Now if we write the range, then r can be written as u square sine 2 theta, that is sine 2 45 degree plus theta, upon g has to be equal to, for second particle, which is u square sine 2, this time angle is 45 degree minus theta, upon g. On solving these two, I can write r to be equal to u square. Now this is sine 90 degree plus 2 theta, which can be written as u square cos 2 theta, upon g. If I square the term, so that will give r square is equal to u to the power 4 cos square 2 theta upon g square. Now maximum heights in the two cases can be written as h1 is equal to u square, angle this time is sine square 45 degree plus theta upon 2g, and h2 as u square sine square 45 degree minus theta upon 2g. On taking its product h1 into h2, we will get u to the power 4 upon 4g square. Here the term will come as sine square 45 plus theta multiplied with sine square 45 minus theta, which can be simplified with the help of trigonometrical identity, and it will give cos of 2 theta upon 2 and square of this, which is equal to u to the power 4 cos square 2 theta upon 16g square. If you compare this with the value we had obtained for r square, so we can write h1 into h2 is equal to r square upon 16. So the given correct option is r square is equal to 16 into h1 h2. Now move to the next question. A shell is fired from a fixed artillery gun with an initial speed u such that it hits the target on the ground at a distance r from it. From here, if it is fired with u, it is striking the ground at distance r. If t1 and t2 are the values of the time taken by it to hit the target in two possible ways, the product t1 into t2 is. This time also r is same. So angles has to be equal to, if one is theta, other should be 90 minus theta. So we can write, if r is same, so that will be, for first, it has to be equal to u square sine 2 theta 1 upon g, and also this is equal to u square sine 2 theta 2 upon g. On equating these two, we got sine 2 theta 1 has to be equal to sine 2 theta 2. Now it can be written as sine pi minus 2 theta 2. As we know that sine pi minus theta gives sine theta only. So it can be written as sine pi minus 2 theta 2. Or we can write 2 theta 1 is equal to pi minus 2 theta 2, which gives theta 2 is equal to pi by 2 minus theta 1. So time of flight now can be written for the two cases, t1 to be equal to 2u sine theta 1 by g and t2 as 2u. This time angle is 90 minus theta 1. So it has to be sine 90 minus theta 1, that is cos theta 1 upon g. If we write its product, T1, T2 will come out as 4u square sine theta 1 into cos theta 1 upon g square. Compare this with the result we get for r. So it can be written as, because 2 sine theta 1 cos theta 1 can be written as sine 2 theta 1. So this will be 2r upon g. The correct option we got is option number D. The next question is, the trajectory of a particle near the surface of earth is given by, here trajectory is given as y is equal to 2x minus 9x square. If it were launched at an angle theta naught with speed v naught, then we have to calculate values of theta naught and v naught. Trajectory equation is provided here. So in projectile motion, if you recall the trajectory equation we had got, y can be written as x tan theta naught minus gx square upon 2 v naught square u. Here it is written as v naught, so I am writing v naught square cos square theta naught. If you compare these two, then it can be written that tan theta naught should be equal to 2 and g upon 2 v naught square cos square theta naught can be written as equal to 9. From here we can write value of v naught, that will be equal to g upon 18 cos square theta naught whole to the power 1 by 2. If we substitute the value of theta naught from here, because tan theta naught is given, so this will come out as 25 by 9 and its root, that is equal to 5 by 3 meter per second. So the value of v naught is 5 by 3 meter per second, whereas angle is, if it can be written in terms of cos theta, then it will come as, because if tan theta naught is 2, cos theta naught can be written as 1 by root 5. So the correct option we got is theta naught is equal to cos inverse 1 by root 5 and v naught is equal to 5 by 3 meter per second, which is option number C. A plane is inclined. Okay, this is the question from projectile motion on an inclined plane. Already we have discussed the topic. At angle alpha is given here 30 degree, which is angle of inclination with respect to the horizontal. A particle is projected with speed u from the base of the plane, making angle theta is equal to 15 degree with respect to the plane. Distance from the base at which the particle hits the plane is close to. So we have to calculate range along the incline. If I draw it here and consider x-axis along the incline, y-axis being perpendicular to it, and let this be the projectile motion. This initial velocity is given as 2 meter per second and angles are, this one is 15 degree and from horizontal it is 30 degree. Now r can be written as range. This I am writing along the x direction. Do remember, when it is asking for range, it can be written in two ways, either along the incline or in horizontal direction. Here it is asking along the incline because it is hitting the plane. So it has to be along the incline. R can be written as, along R I have taken x direction, so it will be equal to uxt plus half axt square, where t is time of flight. We know value of time of flight, we had derived it. That can be written as 2uy upon ay. Now if you substitute values of uy and ay, uy can be written as 2 sine 15 degree and ay as g cos 30 degree. If we substitute the values, that will come as 2u sine 15 degree upon g cos 30 degree. And r is, ux is u cos 15 degree. This multiplied with t, which is 2u sine 15 degree upon g cos 30 degree. minus half because ax is negative. So this is g sine 30 degree and square of t, which is 4u square sine square 15 degree upon g square cos square 30 degree. The value to be equal to 0.1936 meter. And among the given options, this is closest to 20 centimeter. So 20 centimeter is the correct option. The position vector of particle is given here. It is moving according to this relation. So let us first write the relation. R is given as 15t square I plus 4 minus 20t square j. It is asking for magnitude of acceleration. Position vector is provided here and we have to calculate acceleration. So it has to be, according to definition, should be differentiated twice. So first let us see what is the velocity. That should be equal to dr by dt. If you differentiate it once, it will come out as 30ti minus 40tj. This is the velocity we obtained. Now for acceleration, again it has to be differentiated. dv by dt, which is equal to 30i minus 40j. Now as you can see, this acceleration is independent of time. So magnitude of acceleration would be the same irrespective of the time considered here, which is given t is equal to 1 second. So whatever be the time given, it will have the same value. That would be equal to, of course, square root of 30 square plus 40 square, which on solving comes out to be 50 meter per second square, which is option number A. In this question also, position of particle is given here, that is x is equal to at plus bt square minus ct cube. A, b and c are constants. When particle attains zero acceleration, its velocity will be, okay. So first let us calculate the velocity. That will be equal to dx by dt. It will be a plus 2bt minus 3ct square. Now it is given that we have to calculate this value when acceleration is 0. So first let us calculate acceleration and then equate it to 0 to get the time which is desired here. So acceleration will be equal to, now we have to differentiate this again, that is 2b minus 6ct. If we equate it to be 0, the t will be 2b upon 6c. This is the value of t we have to substitute in expression for velocity. So it is equal to a plus 2b. Now in place of t we have to write again 2b by 6c. So it will be square of this upon 6c minus 3c and then square of t, which is 2b upon 6c its square. On solving this, it will come out as a plus b square upon 3c, which is option number C. The next question is, a body is projected at t is equal to 0 with velocity 10 meter per second. Initial velocity is given here, which is 10 meter per second. Then angle also is provided, projection angle, which is 60 degree. The radius of curvature of its trajectory at t is equal to 1 second is r. Okay. Neglecting air resistance and taking acceleration due to gravity, value 10 meter per second square, the value of r is. Now if you can recall, I had told you that r can be written as, for any curvilinear motion, trajectory equation can be written as v square upon ac, where ac is centripetal acceleration. If we write velocity after time t both in x and y direction, x I am here taking as horizontal direction and y as vertical direction. So vx can be written as ux plus axt. That will come out u cos theta multiplied with t, because as we know there is no acceleration in horizontal direction. And vy can be written as u sin theta minus gt. So this is x and y components of velocity. Its magnitude at t is equal to 1 will be, we have to write radius of curvature at t is equal to 1. So V1, that will come out as, this is u cos theta into 1, which is 5 meter per second. Similarly, Vy can be written as, this is u sin theta minus gt, t being 1, its value will be equal to 5 root 3 minus 10. So if this is the velocity vector and let this be angle it is making with horizontal direction, tan alpha can be written as Vy upon Vx, that is equal to 10 minus 5 root 3 divided by 5. That will give you alpha is equal to 15 degree. So this is the angle which velocity vector is making with horizontal direction at time t is equal to 1. Radius of curvature now can be written as, I had written here also, so that has to be square of magnitude of velocity, which is given here 5 square plus 5 root 3 minus 10 square. This is square of velocity upon g cos alpha. Now let us see how I have written this orbital acceleration as g cos alpha. Let me explain. G always has to be in vertically downward direction, and here velocity is making angle alpha with horizontal. So what direction it will be having between g and perpendicular to velocity, because velocity has to be along tangent, and this is normal. So this angle also will be equal to alpha, and we can write component of g along this normal will be equal to g cos alpha. Now if you substitute all the values here, alpha being 15 degree, the final answer will come out as 2.77 meter. That is close to the value 2.8 meter, which is our option number B. Next is the question which had come in NEET 2011. Two particles of mass capital M and small m are moving in a circle of radii r and small r. If their time periods are same, what will be the ratio of their linear velocities? Okay, here time periods are same and we have to write ratio of linear velocities. As we know, linear velocity is equal to omega r. So for particle 1, we can write V is equal to omega r1. For particle 2, we can write V2 is equal to omega r2. As time period is same, so omega has to be same, because we all know omega is equal to 2 pi upon t. So t being same, these values will be same. And we got from here V1 upon V2 to be equal to R1 upon R2. That is R upon small r, which is option number C. The next question is, a particle is dropped from a height and another particle is thrown in horizontal direction with speed 5 meter per second from the same height. The correct statement is, one is dropped and other is thrown in horizontal direction. For both, height is same, h being the same. Let this be the ground here. This is 5 meter per second. Now in first option it is given that both particles will reach at ground simultaneously. Now if we write formula for time when it will reach the ground, for first particle that will be equal to, because we can write h is equal to half gt square. So t we will get as 2h upon g. What about the second particle? Time to reach the ground has nothing to do with horizontal component of velocity. So again it will be written as t is equal to root under 2h by g, which makes t1 and t2 to be equal. So we got the correct statement A. The next is, both particles will reach at ground with same speed. Let us see, is this correct? No, of course it won't be, because vertical component for both will be same, as they have same initial vertical velocity. But the horizontal components are different. One has 0 horizontal component initially, other has initial component 5 meter per second in horizontal direction. So they cannot reach the ground with same speed. The third option is, particle A will reach at ground first with respect to, of course this is not possible because t1 we got as t2, and similarly this D cannot be possible. So A is the correct option here. Let's move to next. From a 10 meter high building, a stone A is dropped. The height is given here 10 meter. and simultaneously another identical stone B is thrown horizontally with speed 5 meter per second. Situation is the same as it was in previous question. And you can see both have come in NEET. Which one of the following statement is true? Of course, here the options are different. First option is, it is not possible to calculate which of the stones will reach the ground first. Is it possible? Of course it is, because T can be written as root under 2h by g, just now we had seen. The second option is, both the stones will reach the ground simultaneously. Yes, this was correct as in previous question. A stone reaches the ground earlier. No. If B is correct, C and D cannot be correct. So this time option B is correct. As from here you can see, the same question can be asked in two different ways. Just sequence of options are different and then it will be a different question. But of course interpretation is the same. Now let us see the next question. Two boys are standing at the ends A and B of a ground where AB is equal to A. The boy at B starts running in a direction perpendicular to AB with velocity v1. Okay, first let us draw the situation. This is the distance AB given by A. Now boy B starts running in direction perpendicular to AB. Let it starts moving in this direction with velocity v1. The boy at A starts running simultaneously with V and catches the other boy in a time t, where t is. It is not clearly written here that what is the direction of running of A, as it seems from the language of question that he has to chase the other boy. So it should be in a direction so as to reach after time t to the point where the boy B has reached in time t. So if we consider this situation, let this be V. The point where the two meet can be taken as C. So we can write now AC will be equal to V into T. And of course BC can be written as V1 into T. From this right angle triangle we can write V square T square is equal to A square plus V1 square T square. And on solving we can write T square taken common, V square minus V1 square is equal to A square. From here this T comes out as A square upon V square minus V1 square and its root, which is our option number B. So this is the correct option. One more question is there. A stone tied to the end of a string 1 meter long. So this is the 1 meter long string and at the one end a stone is tied. It is whirled in a horizontal circle. Okay, so this is moving in a horizontal circle, this point being fixed, and it is moving along this circle with a constant speed. If stone makes 22 revolutions in 44 seconds, what would be the magnitude and direction of acceleration of the stone? As you can remember the things I had taught you in circular motion topic, that if something is moving with constant speed along a circular path, then its tangential acceleration has to be 0. So here also it is the same case. It is moving with constant speed, so AT has to be 0. What about AC now? Centripetal acceleration. This cannot be 0 because it is responsible for change in direction of velocity. And as we know, this is written as omega square r. Now omega is given here. It is making 22 revolution in 44 seconds. Now this is the number of revolution, but we have to write omega as angle made per unit time. So it will be equal to 22 multiplied with 2 pi, because in one revolution it makes angle 2 pi. So in terms of angle, this omega can be written as 22 into 2 pi upon 44 and then square of this multiplied with r. What is radius here? Which is equal to 1 meter. That will come out as, so it is pi square meter per second square. And what direction it should be? This is a centripetal acceleration. So name itself suggests that it has to be towards the center, which is our option number C. With this, our current session is complete with all the questions we have discussed here, which had come in previous NEET and JEE exams. And next we will move to the next chapter, that is laws of motion. I hope you clearly understood all the concepts taught here and now you will be able to solve the questions. Best of luck for your coming exam. Goodbye.